So, first line is mechanics is the study of how and why objects move, but then kinematics is the second line. And if kinematics is the how, that's just trying to distinguish that I'm not worried so much about the why. And so that would be dynamics. And so dynamics is what we're going to talk about after kinematics for the rest of the year, pretty much. The two main types of quantities is going to be a scalar quantities, and scalars have magnitude and unit but no direction. And the other type is, can you guess? Vectors. And a vectors have a magnitude, unit, and direction. So what's the big difference? What's the difference between the two? Direction will matter. Okay. They're designated by algebraic symbols like x or v or t. And vectors, we just add an arrow on top of them. Okay. So their symbols will have an arrow. Linear motion is this is a word where an object is located. Symbol is x, x initial, x final. The SI is meters. This is going to be position, where something's located. And so if I said my x initial is right here, where this person is standing, and then I say my x final is over here sometime later, I would probably use an arrow to describe that maybe he went from 0 to 3. And you're used to seeing this because if I were to describe its change in position, our change in position, what would you do? 3 minus 0, x final minus x initial. If I were going backwards of that, from 3, heading that way, an arrow towards 0, my final would be 0 and my initial would be 3, so it would be 0 minus 3 or negative 3. This is so we can include the direction with that negative sign or positive sign if we're going forward. All right. So linear motion. If I'm talking about a scalar quantity, what's the old word that meant a length traveled along a path? Distance. Good. Distance. And we know that it's a scalar just because we're on the scalar side of the paper. It's split in half. The symbol is x. It's relative to its position, okay, or change in position. The SI units is, what's the unit for distances? Meters, okay. And here's something crazy. Our change in x is actually x1 plus x2 plus x3. That's kind of goofy because when you think about it, this is more like your odometer in your car, where it has the total mileage of your car. It's probably not good to roll it back. That would be illegal because it's trying to describe how much wear and tear is on your engine and your wheel bearings and all of the important things that go on in your car. So this is the total mileage. It should roll forward. So even though it's the change in position, it's your each individual trips added together. Okay. That's different than the high school version or the vector version of this, which is the change in position of an object. You might also hear that it's the change in placement of an object. Displacement. That's what I think of. Total distance, and this one is change in placement. This is the vector version. Its symbol is X with an arrow. And the SI unit is, how would you measure your displacement? Also meters. Just like on your map, right? It would be your change in placement from beginning to end. Okay? So, this one is that our change in placement is X final minus X initial. Just like you would have expected a triangle X to be. This one makes more sense mathematically. This is actually the total symbol, really, when you think about it. Or it should be, mathematically. But for the case of distance, we're just going to add it forward. Alrighty. Distance traveled in a given amount of time. What goes in this blank? Distance traveled in a given amount of time. What do you think that's trying to say? Elementary school word, yep. Speed. Distance per time. It's a scalar. Speed, scalar, speed, scalar. The symbol is V. And the SI unit is meters per second. You just told me that the V, speed, is equal to change in distance or total distance per time. That's its definition in math print. Definition in words makes sense in math print, hopefully. Alrighty. So instead of speed, our vector version is velocity. Oh, some alliteration for you. Velocity is our vector version. Speed, scalar. Velocity, vector. The symbol is, should be super clear. V with an arrow. And the SI unit still is meters per second. So we're going to have V equals X over T. What's missing? Arrows. Same equation. Similar word definition. Displacement per time. Instead of distance per time. Alrighty. Just conventionally. By conventional, I mean a whole bunch of old dead guys got together and assigned these to they had like a convention. They went to a convention center maybe, if those existed at the time. Positive means up, north, and east. So where am I going to put the positive on my map? At the top and on the right-hand side, which means I'm going to put negative signs left and at the bottom. Where would I assign north conventionally? At the top. I'm going to put that in brackets because a lot of times I like to see my directions in brackets. I'm not going to put my negative sign next to my west, but west would be here. I'm going to put it like not in line with each other. Because what would negative west possibly mean? East? That gets confusing. So I'm just going to put it below it instead of next to it. And I guess positive east is still east. So I'm okay with putting those next to each other. I just don't want you to get confused in my notes if you were to see them outside. Alrighty, next page. Moving right along. Graphical analysis. Do this. I already have it done. So I'm going to pull one of those old cooking show tricks on ya and just be like, all right, here it is. Does your graph match? So it gives you a couple bullet points. I'm going to give you about a minute to do that. Alrighty. So, did you get this for your graph? Did it have the nice fancy point protectors? Yes, of course, Mr. Kwan. Oh, you're drawing in circles now, some of you. Okay. Alright. So how would I describe that graph? What kind of words should I have used? Out of the list. Out of the list, out of the list, out of the list. Straight. Wait. What did you say? Straight and increasing. One more. Diagonal. Okay, straight, diagonal, increasing is the three that I had. I just circled them. I'm lying to you. I wrote them earlier. This is first period notes. What is the slope? It literally said that you're drawing it with a constant rate of 10 meters per second, right? So that was the constant rate, 10 meters per second. And what concept is that? Speed. And in my second period, I even said that the slope equaled the change in y over change in x. That on my y-axis was position, and on my x-axis was time. And therefore, position over time is speed. Or maybe velocity. And it depends, really. It depends on how we measure that speed / velocity. So then let's take a look at it then. Instantaneous speed or velocity would be v inst. Okay. V instantaneous. If I had a graph shape, let's do an upside down parabola. All right. So that's my graph shape. How would I describe the speed of this line? If this is a position versus time graph, just like you had, we said that its speed is its slope, but slope from where to where? We'd be looking for its slope at any given instant, right? It would be an ever-changing. This one has a changing slope, right? It's round. Mr. Kwan, it's round. I can't really find it's curved. I can't really find a good place to find its slope. So on round objects, we would say that the slope of a tangent line. What does tangent mean? It touches at one point and it's perpendicular to whatever radial measuring method we've got, like from the focis or something like that, or foci or foci, whatever your math teacher. I don't remember how to do that with parabolas and hyperbolas. Do you remember that? Did y'all have to do tangents to those? I don't remember how that works. So slope of a tangent line to a position versus time graph. Let me just demonstrate it with the ruler because that's a lot of math speak. What kind of slope do I have at the beginning? A lot or little? A lot. So right now it's as steep as the ruler is. That's about as steep as it gets. As I move forward, my slope is decreasing. My slope gets lower and lower and lower. And how would I know that I'm at the very, very, very top? It's completely flat, completely horizontal. Okay? And that would be the slope at that point. I'm not even there yet. And then it starts to slope down, increasingly so. Okay? So, that's how I would look at its instantaneous velocity. I would need its like smallest interval slope. We really don't do that too often in this level of class, but that's the idea behind it. Okay? The other way we could look at it is look at a very small interval and find the average speed. Because if I look at from here to here, the slope between those 2 points, that's not perfectly accurate. It might be close to the whole thing, but that's not accurate for the very first beginning part, right? But what if I had my points from here to here? Is that pretty much a straight line? Yeah? Okay. So I could get closer and closer to it. But right now, we're just going to say that looking at average speeds, it's the total distance versus, or divided by the total time. An average speed is scalar. We're going to call it V, AV, for our note's sake. And V, AV equals, well, we said it already. It's the what versus what? Total distance versus the, by definition, total time. So physics really is just saying it in English and redescribing it, saying it in English, total distance divided by total time, and then saying it in math print, which is total distance versus total time. What do you think average velocity is going to be? Instead of distance, it's going to be displacement. And the symbol is V, AV, but arrow. And this is probably going to be VA. It's probably going to be pretty much the same. VAV is X total versus T total. What's missing? Arrows. Arrow there, arrow there. All right. We're going to get some practice in. So velocity sample problems, just to get you warmed up. My equation is V equals distance over time. I'm looking for a displacement, so maybe I called it a velocity. Do you want to use dimensional analysis to show your work, or do you want to use classic guess method? It doesn't matter to me at this point. I already have my equation down. Both would be considered the substitution of it. Sure. For dimensional analysis, I would start with my easiest unit that I have, that I'm traveling for 5 minutes. That's the one that describes me. Now, what's the problem with this? Why would you do dimensional analysis? We have a mismatch in what units? Time. And so I need to turn my minutes into, how many minutes is in how many seconds? 1 minute. Good. Is in 60 seconds. Excellent. I heard it. And what else? Also, if you think that you're right and you're saying it, I'm going with you if I start repeating even though you're still talking, because I'm trying to not waste time because I'm actually recording these. I don't know if you noticed. We have minutes per seconds defined. What else do we have? Do I have any other conversion? Yeah, meters are 18 meters per every 1 second. So technically that's a conversion ratio right here, 18 meters per 1 second, compound unit. All right. So 5 times 60 times 18, because really what we're saying is that our rate times time is equal to our distance. That's what we would be technically rearranged it to. But I just used dimensional analysis to do that for us. So 5 times 60 is 300 times 18, 5,400 meters. It says displacement. We were heading east. Okay. A car travels 25 meters east in 5 minutes. Even easier because it's already rearranged for us. That what is the speed? V equals x over t. Does our formula change? Or do I just add arrows if I'm talking about velocity? Just add arrows? All right. So my distance is 25. And I have our time is 5 minutes. And our dimensional analysis is maybe I want that in seconds. Did it even say seconds, that I needed it in seconds? It didn't. I don't necessarily need 5 minutes. I have 60 seconds per 1 minute. 25 divided by 300 is something really small. 0.08 0.33. I'll do it for you. I know you don't have a calculator out, some of you. What units is that? Meters per second. That's its speed. How would I record its velocity then? Meters per second east. That's it. Are y'all good with those two? You ready for the next couple? The next couple has car A with the speed, and then they just convert speed. Number 3 converts speed, both in parts car A and car B. I'm not concerned with number 3. Let's skip to number 4. I wanted to do number 4 because this is very important for calculating average speeds or average velocities. When you calculate the average speed or the average velocity, it's not just the average of two speeds. If I'm going 60 miles an hour and 2 miles an hour, the average isn't always going to be 31. It could be 31, but it doesn't have to be. Let me give you an example. If I'm going 60 miles per hour from San Antonio to here, maybe I took a staycation, vacation, and I was in San Antonio, and then I had to get to work on Monday morning, and I drove for 3 hours, 60 miles per hour, and then I got to Cinco Ranch, and I was in our school zone, and I was going like 2 miles an hour for like 2 minutes. Is that just 60 plus 2 divided by 2? And so I get 31? Why? A bulk of my travel is going 60 miles an hour. It's the faster speed, right? And so we would have to have a weighted average, right? We would probably want to calculate the total distance that I went 180 miles plus maybe like a half a mile, okay? And then divide it by the total time that I took, okay? So we're going to do that here. And you'll see it here. My answer should not be 25, even though I'm averaging 20 and 30. Wait, it's off screen. 20 and 30. It shouldn't be exactly 25 because I'm going 20 for 50 seconds. I'm doing distance equals rate times time. If you didn't know where I got that equation, that's the same exact equation. Right? Okay. 20, it's in meters per second, so it's okay to multiply it with the 50 seconds. And that's my first trip, right? 1,000 meters. What's my second trip? 30 meters per second for 40 seconds. So I'm going the 20 meters per second for a longer period of time, so it's probably weighted more towards the 20 than it is the 30. This equals 1,200 meters. What's my total distance? What's my total time? All right. So I'm going about 24 point. Huh? There was an extra 0, so I canceled it out, top and bottom. Did I do it right? Okay. How does anybody have a calculator? Did anybody type it in to their calculator, maybe on their Chromebook or something? 20 what? 24-ish? So 24.4 meters per second. Not exactly 25, right? It's not halfway between 20 and 30. That's my average speed. Do I just staple on the direction for the west or the east? Doesn't work that way, right? If you were on a track or if you were walking around the school building, some of that distance east might cancel out with some of that distance west, right? And it told us that the first trip was east and the second trip was west. So I'm adding 1,000 meters east to 1,200 meters west. I did say west. I did write east. I threw a negative sign in front of it. Negative east is west. Okay. If that's confusing to you, write west, and then you can figure it out later. But I have 200 meters west as my answer, or negative east. In the same 200 meters, very different results, but the time is still the same results of 90 seconds. 20 divided by 9 is 2's repeating. Is it 2.22222? Yep. Okay. 2.22 meters per second. Wait. Leave some space. That's not all our answer. West, right? Does that make sense? The rest of the problems have answers for them, which means that they're to do on your own. I will never do notes checks in this class. I don't think I have any for the grade book. I don't have any room on the grade book for it. So if you show your work or don't show your work, just remember that you're building habits for when you are doing your officialness version of it, or you're going to have to make up for those bad habits that you might have of not showing work. I totally get that too. You have Quest homework. You also might have some time to get finished with the lab.